Hello, welcome. Thank you for joining me, Hornets. I appreciate you being here. I'm going over the pretest number 3. This was a test that I gave about 9 years ago, and I wanted to go through it. I did make an error in class today during second period, and so I am going to correct that one. That one was number 13, where I ended up doing the wrong thing. I used the product to sum to product, and then I used a co-functional identity incorrectly. And using that co-functional identity incorrectly, I was unable to get the correct solution. I had called it a no solution, when instead it is indeed two solutions, 4 pi over 3 and 5 pi over 3, and I will be going through it in just a moment. So in this, we are going through in preparation for our test, which is tomorrow. What I want you to recognize is that we have quadrant 3 here. We know we're in quadrant 3 because our secant is negative and our tangent is positive. So I'm going to set up my reference angle in quadrant 3. You'll notice here is my angle going all the way to here. We are given 4/3 for our tangent, which means that our opposite is -4 and our adjacent is -3, and we have a hypotenuse that's 5 using the Pythagorean theorem. We're then going to set up our sine of this angle, and we'll call it the sine of x. Sine of x is -4/5. The cosine of x is -3/5, and the tangent of x, as we already had it, is 4/3. When we take our reciprocal of the sine, we get the cosecant of x. This is -5/4. The secant is the reciprocal of the cosine, and it is -5/3. And the cotangent, which is the reciprocal of tangent, is 3/4. In number 2, we are attempting to simplify. Now, there's no real easy way to simplify it. You've got a few choices. I can, for example, multiply the top and the bottom here by sine. That'll create a sine squared here. And that would force me to multiply this by the conjugate pair, 1 minus cosine x. And we know that 1 minus cosine squared is sine, which would then allow us to proceed. When I did it in class, I got the common denominator. The common denominator would be sine of x times 1 plus the cosine of x. And that means that I'm multiplying this first piece right here by the 1 plus cosine of x, and this second piece by the sine of x. And I end up, foiling to get 5 plus 3 cosine of x plus 5 cosine of x plus 3 cosine squared of x, and I'm adding to it 3 sine squared of x. Once I have this, I'm going to start adding like terms and get 5 plus 8 cosine of x. This turns out to be 3 when I factor out the cosine of x squared, sine of x squared. I can see that it's the Pythagorean identity, and as a result, it will be equal to 1. The denominator is still sine of x over 1 plus or times the cosine, 1 plus the cosine of x. And now I'm going to go ahead and I'm simply going to multiply and substitute. So 5 plus 8 cosine of x plus 3 times 1, and that'll allow me to add the 5 and the 3 together. This gives me 8, which I can factor out from the numerator, leaving me with 1 plus cosine of x. And I can now see that the cosine, 1 plus cosine of x is going to reduce. And I end up getting 8 divided by sine of x, or I could have 8 cosecant of x. And those would be my answers, one of the two. Number 3 is asking me to factor and simplify, so I can see that the cotangent of x is the GCF. So I have cotangent squared of x as the GCF, leaving me with tangent squared of x plus 1. Now we know that this is the secant squared of x. And the cotangent squared of x can be using the ratio identity, cosine of x squared, and then the sine squared of x. And I know that secant squared of x is 1 over cosine squared of x. Cosine squared of x's will cancel. And I am now looking at my solution, 1 over sine squared of x, or the cosecant squared of x. And that's number 3. Moving to number 4, I'm asked to multiply and simplify. Please don't make this any harder than it has to be. Simply FOIL. If you need to, use the U substitution, but it is a difference of squares, secant squared of x minus 1. This is our tangent squared of x, and that is my answer. Rationalizing the denominator and then simplifying, I want to multiply by my conjugate pair, 1 plus cosine of y, 1 plus cosine of y. This is going to leave me with the sine of y, 1 plus cosine of y, divided by 1 minus cosine squared of y. This is the opposite, so I can factor out, let's just actually do a direct replacement. Sine of y, 1 plus cosine of y, and I have sine squared of y, which will reduce. I therefore have 1 plus cosine of y divided by sine of y, and I'm going to distribute to give me 1 over the sine of y plus cosine of y divided by the sine of y. This will leave me with my answer, cosecant y plus cotangent of y. Number 6 is asking me to verify. Once again, we're going to try and make it look like the right side. So I'm going to rewrite this as the sine of theta divided by this sum, cotangent of theta plus cosecant of theta. That's the sine of theta divided by, now going to change them into their reciprocal and ratio identity. So cosine of theta, sine of theta, plus 1 over the sine of theta. And I can now see that they can have a common denominator, and I can take the reciprocal. This will give me sine of y into the numerator, and we're now multiplying. Sine of theta, cosine of theta plus 1. This gives me the sine squared of theta divided by cosine of theta plus 1. And I can break it up into its identity, which will be 1 minus cosine squared of theta. You'll notice that's a difference of squares. I'm going to rearrange this. Commutative property of addition allows me to move it around. I'm now going to factor 1 minus the cosine of theta, 1 plus the cosine of theta, and I'm dividing by 1 plus the cosine of theta. You'll notice 1 plus the cosine of theta is going to cancel, and I'm left with 1 minus the cosine of theta, and that checks. I have now verified my identity. Now, was number 7 that we actually missed? I did not see that I had missed it in class today, but my goal is to just slowly break it down and notice that it's sine cosine minus cosine sine. This is the cosine of alpha plus beta, which would be the cosine of 42 degrees plus 12 degrees, and that's going to give me the cosine of 54 degrees. And that is now simplified. And my answer. Let's now take a look at the next page. Let's see, we want this one. Here we go. Now, when you're working with this, please be aware you will be given the set of formulas for the half angle and the product to sum, sum to product. So please be aware of that. If you don't have those formulas with you that are handy, you may want to take a moment and just write them down. Once again, these will be given to you. You are expected to know these here, and you are